All right, so today we're going to look at 6.3, which is a math lab. The important thing here is learning how to use our graphing calculator, as well as understanding some similarities and differences between functions. So starting off, Alamina purchased an MP3 player and downloaded 3 songs. Each subsequent day, she downloads 2 more songs. Which graph represents this situation? And explain your choice. So what I see here is that in our graphs, on day 0, she downloaded 3 songs. So she should have 3 songs in her library. So this graph would work for that scenario. Same here. In graph C, it starts at 0 songs on day 0. Well, we know that she started with 3 songs. So I would say that this graph does not represent her scenario. Then each day she downloads 2 more songs. So on day 1, she should have a total of 5 songs. Here we only have 4. It went up by 1 song each day. In this case, we have 3 songs on day 0 to start, and the next day she's downloaded 2 more songs. We're at 5. Then 2 more songs and 2 more songs. So graph B is the best representation of this situation. What we're going to do is we're going to use our graphing calculator. Now, because I can't share exactly what I'm doing on mine, I've downloaded an app to my iPad, and hopefully it's similar enough that we can all follow along with our actual graphing calculator. If you don't have a graphing calculator, maybe try and download the same app either to a phone or an iPad, and see if you can follow along. So we're going to graph the function y equals mx plus 6 for different values of m. So we're going to include values of m that are negative and 0, and we're going to use a table to record our results. So we're going to alter to 1, 2, we need a 0, maybe a -1, and maybe a -2. All right, so I'm going to switch to my app here, and I'm going to, in my calculator, this looks fairly similar to our TI calculators. We want to go to a y equals. And what I'm going to do is we're going to plot a few different graphs. Now this one's going to be really nice and color them for us in different colors. So I thought that this would be kind of nice. So we're going to type in -2, and the X button is right underneath my alpha, and it's actually very close on a TI calculator. It is kind of kitty corner to that second button there underneath mode or right next to alpha. It says X, T, theta, and there's a bunch of different labels on it, but that is our X button. So -2x plus 6 is what we wanted, and we want to change the X. So we're going to have a -1x plus 6, and we need to try a 0x plus 6, 1x plus 6, and I'll do 2x. Plus 6. You can do more. This is going to be a lot to begin with. So once we have graphed them in our y equals, what we're going to do is we're going to say graph, and that should take us to our graph. I'm just going to hide the calculator for a second. Now we're going to have a lot of different graphs here, and yours may be stretched differently. TI, typically goes to a zoom of 10 by 10. So yours will look a little bit different. So I can hover here, and it does tell me in the very top left corner that this is the graph of -2x plus 6. Then we have the graph of -x plus 6, 0x plus 6, +1x plus 6, and +2x plus 6. In our graphs, what is similar in all of these cases is where they cross the y-axis. Okay, so they all cross the y-axis at, in this case, it's +6. My axes are, each box here is going up by 2. all right, in the y, and in the x, it looks like it's going up by a different value. So I don't really like that. Let's see if we can change the window. So the same thing on our calculator, we can change the x minimum, the x maximum, the x scale, y min, y max, and I'm going to change the y scale to 1 as well, just so that it looks consistent. And it'll probably be more like what yours is. All right, this feels a little bit more natural. Again, they're all still crossing at 6. So what does changing the value of m change in the appearance of the graph? What it has changed is our slope. So our slope here is 2, positive 2. And then this one is positive 1. This one we have a negative 1, a negative 2. So what's changing is slope. What is the same is our y-intercept. Because our slope is changing, our x-intercepts are changing as well. Okay, so you could fill in the table of values in our chart here. So our y-intercept was positive 6 in all cases. The slope of the graph was negative 2, negative 1, 0, 1, and 2. And the x-intercepts you could record. There is no x-intercept for the graph where m equals 0, and that's because we had a graph where it crossed at positive 6 and never touches our x-intercepts or our x-axis. So what does m represent then? Well, m represents the slope of the graph because they are identical. Graph y equals 2x plus b for different values of b. We're going to include values of b that are negative and 0. So once again, I'm going to do, I'm probably not going to do 6. I'll do negative 1, negative 2, negative 1, 0, 1, 2, and then maybe I'll put 6 at the end. We're going to record our results and see what we get. So back to our calculator here. What you're going to do is you're going to want to clear all of the graphs that we've done. So if you use the same button, if you go to y equals and then clicking on each one or thumbing up and down, use the clear button. And we should be able to have a clean slate here. So we are graphing 2x, and then we had negative, take away 2. We had 2x, take away 1, 2x, take away 0, 2x, and then we're going to switch to positive 1, 2x plus 2, and I'll throw in the 2x plus 6 just to graph it. Once you've got all of your y equals, go ahead and hit graph. Hopefully it's maintained the same window here for us. It looks like it has. Now, what do we notice about all of these graphs? So what's the same? Well, all of these lines are parallel to one another. Now, again, in the top left corner of my screen is where it's reporting what our equation was. So the one that I've got highlighted here, orange, is 2x plus 6. So the 2 is, again, our slope. We start and our rise is we go up 2 and over 1. Okay, to go to the next, or down 2 and over 2. I'm not sure what just happened to my window. I'm just going to quickly adjust. Sorry. New to this program. Okay, so then let's start investigating some of the other graphs. This one is the graph of 2x plus 2. So again, our slope is 2, so we're up, rise 2 over 1. And what could we say about the positive 2? Well, in this case, it kind of looks like that's our y-intercept. It doesn't describe the x-intercept. Our x-intercept is negative 1 here. So that doesn't seem to be the case. Okay, well, let's take a look at here and see if we can see the same thing. So we have 2x plus 1. That plus 1, again, seems to represent where this graph crosses the y-axis. 2x minus 0 or plus 0, it crosses at the origin, or 0. 2x minus 1 crosses at negative 1, y equals negative 1. And 2x minus 2 crosses at y equals negative 2. Again, we can go and record all of our x-intercepts. This one appears to be a half, and 1, 0, negative 1/2, negative 1, and then we also have negative 3 over here. If you want to record those, I'm not going to be able to remember to put that into our calculator or our table here. Okay, what I do remember is that the slope of all of these graphs was 2. The x-intercept and the y-intercept were all changing. The y-intercept was always the same as the value of b that we put in. And again, the x-intercept, I think it was negative 3, negative 1, negative 0.5, 0. Oh, sorry, that was up here. Those were for these ones. My apologies. We had a 6 as well, so that was negative 3, negative 1, negative 0.5. 0 was on the nose there. Positive 0.5 and positive 1 for those guys. So how does the changing value of b change the appearance of the graph? It changes the y-intercept. Therefore, b must represent the y-intercept of our graph. So predict the appearance of the graph of y equals negative 2x plus 4. Remember, the kind of general form we looked at here was mx plus b, where m was our slope and b was our y-intercept. So in this case, m is equal to negative 2, because it's what's multiplied to x out front, and b was positive 4, positive because it's added here. So if that's the case, we could quickly draw a little graph here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And we could even plot this. So our y-intercept is at positive 4. I should maybe draw a couple more. And our slope is negative 2. So that means rise over run is negative 2, which is technically over 1. So our rise is negative 2. We're going to head down 2 and over 1. And we could draw a point there. We can do that again. Down 2 and over 1. Down 2 and over 1. Down 2 and over 1. So our graph should look something like this if we were able to put it into our calculator. So our y-intercept looks to be positive 4. Our x-intercept appears to be positive 2, and we have a slope of negative 2. Let's see if that's the case. Let's go back to our graph. So back to y equals, and we're going to clear all of our previous graphs. And we had negative 2x plus 4. Let's graph and see what happens. Looks pretty much like that rough sketch we just did. The y-intercept is at positive 4. We move down 2 and over to the right 1. Down 2 and over to the right 1. And we get an x-intercept of positive 2. All right, now you can also trace the values and it'll show you what they are. If you were on your calculator, you can hit trace and it'll report all of the values, what our x is in the bottom left, and approximately the middle in the bottom will be a y. You can try a bunch of these different things here. We can zoom in. We can draw different things. Again, we can trace. We could calculate, if you go second trace, we could calculate a value in our graph, a minimum, maximum, intersection. We can look at a table of values for our graph, hitting second graph. There's a bunch of different things. So try exploring those and see what you can see. I know this wasn't in our notes, and I didn't really account for it in our learning plan this week. So I would recommend that you take a look at questions 4, 5, and 6 on the next page here, on page 356. It asks to predict what's common about a couple of equations, predict what's common about another set of equations, and then graph without using a table of values. So kind of like we did on this question here.